This is linear programming classwork number 2. A gold processor has two sources of ore, source A and source B. In order to keep this running, at least 3 tons of ore must be processed each day. Ore from source A costs $20 per ton to process. Ore from source B, $10 per ton to process. Costs must be kept to less than $80 per day. Moreover, federal regulations require that the amount of ore from source B cannot exceed twice the amount of ore from source A. If ore from source A yields 2 ounces of gold per ton, and ore from source B, 3 ounces of gold per ton, how many tons of ore from both sources must be processed each day to maximize the amount of gold subject to the above constraints? Well, it looks like they talk about source A and source B, so those are going to be my two let statements. And in particular, they mention tons of each source. So let's let X be equal to the tons of ore from source A, and we'll let Y be equal to the number of tons of ore from source B. And as far as our objective function, we're looking for the words maximum or minimum. And here it looks like they're talking about you want to maximize the amount of gold that's extracted. So I want to maximize the amount of gold. And it looks like right over here, ore from source A yields 2 ounces of gold per ton. So since X is the number of tons from source A, 2 ounces per ton would be 2X, and ore from source B, 3 ounces of gold per ton. So that's going to be 3Y. So that's going to be our objective function, 2X plus 3Y. So the objective function, you just look for the words maximum or minimum, and that usually pushes you in the right direction. But the constraints, the inequalities, sometimes are more difficult to write. For example, right over here it says, at least 3 tons of ore must be processed each day. So if I take X, the tons produced from source A, and I take Y, the tons of ore from source B, and I add them up, it needs to be at least 3. At least is bigger than or equal to 3. Now, it talks about costs right over here, and it says costs must be kept to less than $80 per day. So I need costs to be less than $80, less than 80. And if I go find the costs, right here it says, ore from source A costs $20 per ton. So that's going to be 20X. And then from source B, it says $10 per ton. So that's going to be 10Y. So that constraint is going to be 20X plus 10Y is less than 80. Now, it also says this, and this was the federal regulations part. It says the amount of ore from source B cannot exceed. So if I take the amount of tons from source B, so that's going to be Y, that cannot exceed, cannot be bigger than. So that means less than or equal to. Cannot exceed, cannot be bigger than. So that means it has to be less than or equal to. cannot exceed twice the amount from source A. So that's going to be 2 times x. So that's how we write that constraint. I think we hit all the numbers and all the sentences. So lastly, I'm going to look for my minimum value constraints. And I don't have any minimum value constraints thus far. X is the number of tons from source A. And I don't have like x has to be bigger than or equal to 10. So I have to throw in x is bigger than or equal to 0 because you can't have a negative number of tons of ore. Same difference for y. We're going to throw in y is bigger than or equal to 0 because that's going to be the minimum value constraint that we need for y. So when you get done writing your constraints, you then have to go through and see, do you have minimum value inequalities for each variable? So now what we're going to try to do is we're going to try to graph all 5 of these constraints on the same graph. We want to try to find the solution area. And then more importantly, what we want to do is we want to find the vertices, the corners of the solution area. So take a minute, enter those inequalities into your calculator, and let's try to go about finding the solution area. So when you have your inequalities entered into your calculator, I have my y equals screen shown below. Remember, for each of these inequalities, you have to get the y by itself. For inequalities, when you multiply or divide by a negative, you have to flip the inequality sign. But I don't believe that rule applied to this one here. Make sure you have your details correct. When you change the inequality sign or flip it around, it could cause your solution area not to show up at all. And what I'm going to do to start this question, since I have these 2 minimum value inequalities, x is bigger than or equal to 0, y is bigger than or equal to 0, I'm going to start off by going to zoom and then scrolling down to option A, which is zoom in quadrant 1. What that's going to do is it's going to make the minimum values 0, so my x and y mins are going to be 0, and that corresponds to these 2 minimum value inequalities. And your calculator makes the maxes about 13. It's been programmed when you go to zoom and then A to graph up to about 13 for both the x and y axis. I'm going to hope that that's going to be enough in terms of answering this question. I'm looking at my numbers here. My numbers are not terribly large since I have 20x equals 80. That means the x-intercept is going to be 4. And here I have 10y is 80, so my y-intercept is going to be 8. So I think this viewing window, if I go to zoom in quadrant 1, is probably going to be good enough to get my solution area. For those of you using the older, more reliable graphing calculators, what you might want to do to make sometimes the solution area a little bit easier to read is just change your mins to a little bit negative, so that way it slides the graph up to make the vertices a little bit easier to see on the screen of your calculator. Remember, when you graph these, you have to graph it twice, and the goal is to come up with the inequality intersection on your graphing calculator. And it looks like there are going to be 4 vertices, 4 points that are the corners of your solution area. What you're going to want to now do is you're going to want to use the point of interest, the POI feature of the calculator, to get the coordinates for the vertices. So the four vertices turn out to be 3, 0, 1, 2, 4, 0, and 2, 4. Those are the four vertices for the solution area. Those are going to be your possible x and y values that you're going to plug in to the objective function. Here we're trying to maximize the amount of gold that gets extracted. So our objective function was 2x plus 3y. So now you're going to, one at a time, plug in your x and y's. So you're going to do 2 times 3 plus 3 times 0 for that first vertex. Then you're going to do 2 times 1 plus 3 times 2 for the second. Then we'll do 2 times 4 plus 3 times 0 for the third. And then finally we'll do 2 times 2 plus 3 times 4. So you plug in each vertex, the x and the y, you plug them back into your objective function to answer the question. So we're looking for the maximum value for these four expressions. So it looks like here the maximum value that we get is 16. So the maximum of 16 occurs at this vertex, the vertex 2, 4. So what does that mean? That means they should process 2 tons of ore from source A and 4 tons of ore from source B every day. That's how they maximize the amount of gold that gets extracted. And that's why linear programming exists, to find maximum values and minimum values of expressions of the objective function.